we'll get started. Happy Monday, everybody. Tomorrow is Tuesday, and it's the end of the month, October 31. So that's exciting. Okay. All right. Well, today we'll cover GGPlot 2 and the grammar of graphics. We'll do this today and tomorrow. Not tomorrow. Wednesday. But let's talk about our midterm exam on Friday, okay? So this is kind of the format of the exam, all right? Most of the questions, I'm going to write some kind of code, and we'll ask you what will our output for the code provided. The code is not going to be elegant, and it's not going to use best practices, right? Anyone, if you have well-written code, anyone can understand what's going on, but the test is going to see if you understand not good code, okay? And it might be a little bit on the harder side. Students in the past complained it focused too much on the details of our syntax, but that is exactly the point of the test, okay? Right, because I mean, if I said, what will our output if you do 3 times 4, everybody can do that, okay? But then if I give you something weird, can you figure out what R is going to output? That's a little bit more important. And if you ever go for a technical interview, a lot of times they do ask you weird questions to just kind of separate you from a casual programmer to someone who knows what they're talking about, okay? So here's here's an example, all right? So let's say we've written this function f, all right? So if we run this, you can think about this. What will f of x output, and what will x output? Do we have it? Have we figured this out? You might need to write something down on paper. So if we have f of x, what will we get? So right now x is 4. So we would plug 4 into the function, right? It's a function of y. So currently our y takes on the value of 4. Yeah. Okay. So then we will have 4 plus 0.5. Y is 5, but I'm running the function f of x. Oh, see, all right, you guys got that wrong already, okay? It's a function of y, but so I'm writing, basically what I'm putting in is f of 4, okay? This is not f of x, it's f of 4, okay? So right now our function has y equal to 4, so I've got 4 plus 0.5. We're going to superstore that as x. So x in the environment now has the value of 4.5, and it's going to return 3 times 4.5, which will be 13.5, right? So here we can double check this, make sure I'm not making this up here. Okay. So I have this. Here's my function f. All right, and then I've got x is equal to 4. Oh, sorry. Oh, what happened to my thing here? Okay, we need to make everything bigger for you guys. Okay, so we have x is 4, and then what did I say? Y is 5. Okay. All right. So when I run f of x, it will return 13.5, and if I ask what is the value of x, x is the value 4.5, right? Okay, because of the super assignment. Okay, so it'll be, that's like an example of one thing, all right? Obviously, this just tests kind of functions and scoping, but we've covered a lot of topics, and so I'll throw a bunch of weird stuff at you, okay? And you'll do your best. Yes?
So when you use the super assignment, it also assigns value to x inside the function. So it's like when it drops down to the next line.
So it does not assign x inside the function. It assigns x outside the function. This call 3 times x says, I don't have an x inside the function. I've got to search the outside scope. Okay, and so we'll find 4.5 in the global environment and return 3 times. Yeah. Okay, but if I got rid of if it was just regular assignment, then x inside the function takes on the value 4.5. It still returns 13.5, but then the global x remains 4. Okay, so this is so pretty much everything. Oh, not from, but everything through week 4 Friday is fair game for the midterm. So from day 1, so that's what, week 0 Friday to week 4 Friday. It's fair game for the midterm with the following exceptions. So I said, you know, these slides, so calculations involving infinity and not a number or dividing by 0, those types of weird things. Subsetting with out-of-bound indices. So this would be things like if you try to subset a vector using null or using NA or using, well, NA always returns NA, but you know, something out of bounds, and it behaves differently with lists and vectors and things like that, and sometimes it kicks back an error and things. I will not test that, okay? You don't have to worry about functions that return other functions. That was like a weird thing on one of the slides. We'll not cover S4 or reference class object-oriented systems, but S3 is covered, okay? Date conversions without lubridate, so all those weird formatted things with date conversions, and the dplyr join functions, so the left join and inner joins, those are not covered, okay? Everything else we'll say is fair game for the exam, and you can expect something where I've given you some code and I ask, what R is that going to output? Okay, it's going to be a paper and pen exam, so, or paper and pencil. So we'll come to class, I'll pass out papers, you'll have your pencil, and you'll write down your answers. Okay, questions? Yes?
So just to be clear, for that last slide, you said you printed X and just returned 4, right?
This one, as it's written here, X will return 4.5. Oh, 4.5. If I don't have super assignment, then X would return 4.
The test will be in here.
The test will be in here, yes. Okay, so just come to class like regular on Friday with a pencil. Okay, no, you can't have your computers out or something. Okay, yeah. Question.
For questions that we're just running, like what will it output? Will those be like all or nothing, or will there be partial credit?
So there will there's like. Yeah, I guess each one is a little bit all or nothing-ish. There's probably multiple parts to each one, okay? So I'll look at kind of, you know, what you get here is counted separately from here. I mean, some things, there will be, I guess, some partial credit. Like, for example, if I write a loop and it has cat or versus print or something, right? Like cat would output the results on the same line, okay, unless I have a /n character, and print would put everything on its own line with bracket 1s, yeah? And so if you get one of those mixed up, I would give you some partial points, even though it's not technically correct, okay, because you might have shown that you understand at least parts of it, but maybe you didn't get the print portion correct. Okay. Other questions regarding the midterm? Yeah, it's all short answer. Yeah. How many questions? I don't know. 45 minutes worth? Okay, so. Huh? It's not a lot of time, huh? Like, how much time should I have given you for this one, right? Like 3 minutes? 4 minutes? 3 minutes? I feel like that's enough, right? You're either gonna get it or not in that 3 minutes of time. You're either gonna think X should be 5 or that Y should be 5 or not, and I don't know. Okay, let's talk GGPlot. GGPlot. So I know some of you guys have covered this already. GG stands for Grammar of Graphics. It's created by Leland Wilkinson, and it provides a very formal, structured perspective on what data visualization should be about, okay? But you know, anytime I introduce GGPlot, I do say this is not the only graphics system that can be used, right? We have base graphics, and you know, the plot function in R is very, very convenient because almost every package comes with its own plot method. So, or you know, almost every object carries its own plot method. So if you have you create a linear model object, you can just say plot on the linear model object, and it produces a bunch of plots. So it's super convenient to use plot because they'll have their own methods, but and GGPlot will not have those methods. A lot of those plots you can recreate in GGPlot in a nice way, but maybe not. But GGPlot, you get really pretty looking things, and you do have well, it's good, and you can change things up on the fly. All right. So the whole idea of the grammar of graphics is that we are mapping properties of the data to properties of the graphic. Okay, so things like in the data, properties of the data are going to be either your columns of data, which are generally going to be numeric or will be categorical. Okay? And then what you do is you map those numeric variables to some kind of attribute in the graphic. Okay, and so for numeric data, we're very much accustomed to mapping numeric values to a position along the x-axis or a position on the y-axis, right? That's probably the most traditional method of mapping a data property to a visual aspect. But we could also map that number to the size of a point. Okay, so if the number is small, it's little, and if it's big, it gets larger. Or we could map it to the intensity of color. Okay, so it could go from a white to a black and grayscale type of thing. And so like small values will be very light in color, and large values will be very dark in color, or things like that, right? We can map basically a numeric attribute to a graphic property. And then on the other hand, we have categorical variables, and those could be mapped as well. You could map them to X position and have like this position on the x-axis correspond to this category and this category and this category. Or you could have them mapped to things like the color of the bar or the point, or the shape of the dot that you're using, okay, from a circle to square to triangle. We are just going, instead of the table saying this is category 1, category 2, and category 3, this is going into the graph saying this is square, circle, triangle, or something like that. Okay, and it might, in the beginning, it might feel like mapping an attribute to the x coordinate feels different from representing the attribute by a color scale, but at the heart, it's the same idea. It's just, are we using, you know, what kind of graphic attribute or aesthetic are we using? Okay, and the more you kind of get used to this idea, the more all of this GGPlot stuff and the mappings will make sense. Okay, so a lot of this stuff I'm using from the R Graphics Cookbook. Okay, that's available to you for free via Safari Books Online, which, while you guys are here at UCLA, you should really take advantage of that resource if you're not doing so. Okay, and here we're looking at this data set right here. Okay, so we've got a simple data set, and it shows kind of we have two categorical variables. We've got A1, or we got the A categorical variable, which has 3 categories, A1, A2, and A3, and we have the B categorical variable, which has categories B1 and B2, and then we have this two-way table which kind of shows the counts of each of these things, right? And we can plot this using base graphics, using a bar plot, okay? And this shows us the counts of A1, A2, and A3, and also whether we have, what do we have, 10 of B1, A1, and 9 of A1, B2. So we have that. And that's represented with this bar chart. Okay? If we wanted to switch things around and have the B on the horizontal axis and A being the different kind of shadings, this would require us to reformat the structure of the data, okay? And so to do this, because bar plot, the way it takes in its arguments is by looking at a two-way table, we would have to transpose the matrix, and we would have a two-way table shaped this way, and then we could plot it using bar plot, okay? And we would have, and the same data would be represented this way, okay? And this is kind of the biggest difference between base graphics and GGPlot. In base graphics, each of these plots, such as bar plot, okay, or you know, whatever else you might want to use, a lot of them have their own formatting for how the data should come in, okay? Does the data, you know, here for these things you'd have to look at the help and you'd say, okay, I need to format my data into a two-way table. Okay. And likewise. If we wanted to do something with lines instead of bars, okay, we could call we would call a plot to create a new graph, and then we would draw a line for one row of data, and then we would draw a second line using the command lines. And the resulting graph, which I'll show on the next slide, is that the second line will run below the visual range, okay? And the reason for that is that the range of the y-axis was set when we plotted the first line, okay? When we plot the first line, that establishes the range of the y-axis, and then when we add the line for the second line, okay, and that goes outside of the range established by y, then it goes off the of the chart, okay? So and then we'll also notice that the x-axis is numbered instead of categorical, and so this is kind of the result, right? So this is the equivalent of this thing where it goes from 10 to 7 to 12, and over here it goes from 9 to 11 to 6, and that's what we have here. But because the y range was established when we first created this plot, the plot down to 6 goes down, okay? And then the index, which is really should be categories A1, A2, and A3, those are represented as if they were numeric, which is not the case. I mean, we can figure this out, but you know, if you looked at this at first glance, you might come under the impression that it's a numeric variable. Okay. If we wanted to do things in GGPlot 2, you know, we would have to do some restructuring of the data, but the restructuring of the data would be in tidy form. Okay, so rather than having a two-way table to represent our data this way, we would have one observation per row and one column per variable. So we'd have column A, which is either going to be A1, A2, or A3, and we'd have column B, which is either B1 or B2, and then we have a total of 6 different values, and those go right here. Okay, and so this is the tidy format, and now we would map each of these categorical variables to some kind of attribute. Okay, so if we want to make the first kind of bar graph, what we want is we want to map this column A value, whether it's A1, A2, or A3, we are going to map that to the X position. Okay, so things that are A1 will come over here on the graph, things that are A2 will go into this X position on the graph, and A3 will go into the kind of the third position horizontally, okay? And then we want to change the colors of the bars determined by the b-values, whether it's b1 or b2. And so that for that, we will map b-val to the fill attribute, which is going to be the color of the bars that we use. Right? And then the value of the these things, 10, 9, 7, 11, 12, 6, that gets mapped to the y attribute, how tall the bar is. And we'll tell R to draw bars using geombar. Okay, so our command here is we take our data, we say we're mapping x to the a values, y to the actual value, and the fill is going to be b value. Okay, geombar, we have a few things: stat equals identity and position equals dodge. This gives instructions to R regarding you know, should we plot the things on top of each other, or does it need to calculate any kind of summary values here? But this produces the graph here. If we wanted to switch things so that we have going from B1, the B variable on the horizontal axis, and the A being the different colors, we would just switch the X to be the B value and the fill to be the A value column. Okay, so we'll set X to B value and fill to A value. We don't have to do any changes to the data. What we're doing is we're changing the mappings for the graph. So in this case, same commands as before. The only change here is we said the aesthetic mappings, that's what this AES command is. We're saying the B values get mapped to X, and the A values are mapped to the color, the fill. Okay, the height of the bar is still going to be our value column Y. Okay, if we wanted to change to the line graph, okay, what we have here is our aesthetic mapping is we are using the A's for the X, okay, and then the color of the line is going to be our B value, and then and kind of the groupings of our line is also the B value, and we are saying the height, the Y, is still the value of the column, and we're going to say draw lines, geom underscore line. All right, and I know this feels like earlier on when you're learning ggplot 2, you feel like I can't remember all of these, how these aesthetic mappings go, and you know, what are these special things I need to use for each geom bar and geom line and all of this. Okay, I get that, because it feels weird in the beginning. And my answer to that is, just like everything else in life, in the beginning when you're trying something out, it's going to feel a little bit awkward and clunky, and you're probably not going to be very good at it. But with practice and exposure, you will get better, and some of these commands will come a little bit more naturally to you, right? And so I think, especially for things like ggplot, the best way to learn is by looking at other examples and trying to see if you can change or modify someone else's example to fit your needs, right? And so kind of the big resources for that is the R Graphics Cookbook. Okay, so take a look at this. So it's already 12 years old, but I'm not 12 years old. It's already 5 years old, but it does produce a lot of things, and so you can just kind of create different bar plots and things like that, and then the other place is ggplot. Just search for ggplot 2, and you go to the documentation. Okay, and you can click any of these things for geoms, these are things like, so if you're not sure, you can, okay, I want geom underscore bar, and this gives you a bunch of, at the bottom here are all the examples that they run, okay? And usually you can probably find something that says, ah, this is what I want, and you would pick, kind of modify the things from there, right? So, you know, as far as the lectures that we'll cover, or the geoms that we'll cover for this class, we'll just look at some of the basic ones, right? So just kind of, again, to kind of recap, with base graphics, we had to use completely different commands to make line graphs instead of bar graphs. With GGPlot 2, the main change was that we said we are changing the geom that we're using from bars to lines. Okay, so here we had geom line, and over here we had geom bar. Yes, there were a few other additional attributes that we had to change, but overall, the structure of the command that we're giving it was the same. And then, you know, those quirks of base graphics went away, and then GGPlot 2s generally will also create legends for us automatically, which I don't know if you ever tried to create a legend in base R, but it's a pain in the butt, right? It's not a lot of fun. So if you with GGPlot 2, it often creates legends for you automatically, and you know, if you want to customize the legend, it's easier, in my opinion, it's easier to customize the legend in GGPlot 2. Okay, so some terminology to talk about when we're doing GGPlot 2. So we've got, obviously we have our data. The geoms are the geometric objects that we are drawing to represent the data. Are we drawing lines? Are we drawing bars? Are we drawing points to represent the data? Those are the things that go into geoms. We have aesthetic attributes, which are all properties of the geometric objects, right? So if you're drawing points, a point has a few aesthetic properties. One is, where is it positioned on the X and Y axis, okay? Those things are aesthetic attributes of the point. Often the shape of the point, the size of that point, the color of that point, those are all aesthetic attributes of the of that geometric object, the point. And even like its transparency, which probably is not a good thing to use as far as something to represent, but just because our eyes aren't really good at distinguishing transparencies, like different levels of transparency, but I mean, you could do that, right? And then we have to create mappings between these aesthetic attributes and the data, right? We have scales. Scales control how those maps go, right? So if you want to map a numeric value to the color of your bar, okay? So let's say you're using the geometric object that you're using as a bar, and you want to map the color to that thing, you can establish a scale. So the scale is going to say, you know what, we want values of 0 to be white and values of 10 to be black, and everything in between is some shade of gray, okay? Or maybe you want to go from yellow to red, okay? Like a forest fire warning. So maybe it's like green to yellow to red or something like that. And you can say like, you know, if the threat level is 0, then it's going to be green, and then as it climbs to, you know, threat level 10 or whatever, or 100 or 5, you know, it changes from green to yellow to red or something like that. So that's going to be established with the scale. Same thing with categorical variables, except the scale is going to be like category 1 is a square or something, okay? And then the guides are then things presented on the graph so that the person looking at the graphic can figure out the numeric values of the data or the categorical values of the data from looking at the graphic, right? Because there's a process. When you are doing data visualization, you are taking your raw data, you are putting it into a graphic, That's the visualization part. But that's only useful if the person viewing the visualization can then take the visualization and turn it back into data in their own brain, right? Otherwise, we would just say, hey, here's the original data, look at this data, and then that would be fine. But a lot of times when we map things, there's like, we can see patterns and things like that because our brains have developed, I don't know, ability to recognize shapes and things. And so, you know, we want to map the data to these visual aspects, but it's important that the person looking at this graph can then understand what it's saying, right? And a lot of times, you know, some people keep blogs on just terrible graphics, right? Data graphics in newspapers and stuff, because there's a lot of terrible ones where they try to use, like, I don't know, funny shapes for something, which just ruins our ability to map the visual properties back to the data, okay? So common things are tick marks or labels on the axis, but just also any kind of legends, right? Okay, so typical data visualization scenario, we've got data, we're gonna have geometries, we will add aesthetics, and then we'll add scales, okay? All right, so let's see. Yeah, this is basically what I said. Okay. So the variable types will determine the aesthetics. Okay. So obviously, certain aesthetics only work with categorical ones, such as the shapes. Okay. Some things will work both with categorical or numeric ones, such as the horizontal position, and other things, you know, make more sense for numeric versus categorical, right? Okay, so to build a simple graph, your data has to be stored in a data frame, and each type of the variable that is mapped to an aesthetic must be stored in its own column. So basically, you need to have tidy data in a data frame. Okay, if you're gonna try to map something, basically, yeah, every attribute you're mapping has to be in its own column. That's kind of the biggest important thing. Okay, so let's say we have this. We've got the x value, the y value, and a grouping variable. Okay, so here we have a data frame. So we've got two numeric variables, x and y, and then group we have a and b. Okay, so that's a categorical variable. So if we wanted to graph this, you know, when we look at this, it probably makes the most sense to say, all right, we'll take the x value, put it on the x-axis, the y value, we'll put it on the y-axis, and we will pick some kind of categorical trait for the grouping variable, okay? So we start off using GGPlot, and we're gonna say, we're gonna look at taking the data in DAT for a data frame, and we're gonna say the aesthetic mapping we are creating is to map the column x value to the x-axis, the column and the y value to the y-axis. And this is going to establish our plot without any geometries right now to represent the actual data itself. It just says, okay, here we go. And GGPlot automatically establishes a scale for both the x and y-axis and labels them accordingly. Okay, so this is what we have. We've mapped the x value to the x position, and we need to say what kind of geometric objects to put there. So we will add geom_point to say draw points to represent the data that we have. Okay, so we say geom_point, and it puts our data on there. So we've got 1, 3, 2, 5, 3, 6, and 4, 9. Okay, our 4 data points. Now, if we wanted to add in the aesthetic, another aesthetic attribute, we want to be able to show the grouping variable. Okay, that's a categorical variable. So we could say, let's map that categorical variable to the color in our data, right? So we're going to say we want the color of our points that we are drawing. We want that to depend on the group column. So if we do that, it's kind of hard to see, but GGPlot will say, okay, I recognize that group is a categorical variable. So I am establishing a legend here to say that the red is A and the blue is B, and it has mapped the colors accordingly. Right? That's a mapping, because here the color depends upon the values in the group variable. Okay. However, there are settings. You can say, you know what, I want all these points to be big, or I want all the points to be blue. Okay. And so here we're going to just say color equals blue. This is a setting. This is not a mapping, because the color blue carries with it no meaning to the data, right? Seeing that a point is blue does not tell us anything about the data itself. So this is not a mapping, it is an aesthetic setting, all right? And it allows for us to have that, and we've got color equal to blue, okay? I've also, I forgot to mention that back here we said GGPlot, we're creating our initial plot and we're storing it as P. So P now represents our call to GGPlot, and then we can just say P plus the geometry point, or P plus something else. So we don't have to call entirely GGPlot plus geopoint every single time. We can just say P plus this thing, or in this case P plus geopoint with the setting color equal to blue. Okay. Here we can change the limits of our scale. Okay, so right now our scale takes on kind of the default values of 1 through 4, but if we wanted to, we can change the scale using scale x continuous. Now again, all of these things you might say, well, how do we remember any of this stuff? You can always go to the GGPlot documentation and come over here and say, like, okay, what is it that I want to mess with? I want to change a scale, and a lot of times they will have all sorts of options as far as things you can change. You want to change things onto a log scale or something like that, you can do that. You can change the scales for the fills or things like that. Okay, so changing the scale to 0 to 8, here we can see how that has affected the way our data looks, right? And suddenly our data, changing the scale often changes our feelings and attitudes towards the data, right? So I don't know, you look at this and it looks kind of like we kind of see the range from 1 to 4. And this graph, although it's the exact same data, suddenly, I don't know, in my opinion, takes on a different feeling in terms of it, because now we see kind of this scale here, right? And so this is a trick that a lot of people can abuse, and I'm not saying endorsing this, but these are things that you have to be aware of when you're creating your graphics. All right. Back here we said we wanted to map the color to the group, and here we can set the colors manually ourselves, right? So just keep in mind, because it was created by Hadley Wickham, who's from New Zealand, he spells color with a U, and now we can say, all right, I want orange and forest green as our colors here, and it's hard to tell, but they really are those colors on on the plot, okay? It looks really dark up on the, or it looks different on my screen than it does your screen, but that's what we have. Okay. This is okay. This is an important thing to note. Okay, in the base graphics, the graphing function tells R to draw graphs to the output device. Okay, which is generally the screen, or you can say dev.pdf or something, and it creates an output device, which will be a PDF file. Okay. With GGPlot 2, the commands don't directly draw to the output device. Okay. Instead, they build plot objects, and the graphs are only drawn when you call in print the object. Okay. And we haven't asked R to print any of our graphs explicitly. Okay. And that's because in R, when you generally type in something, you type in like 4 plus 5, okay, it does that computation 9, and then there's a default thing of taking whatever that thing returns and printing it. So it'll print out 9, and so it says bracket 1, 9. And so when we've been calling ggplot so far, it's always been printing these things out. Okay. However, if you write a script or you're writing a loop or something and you're creating plot objects and you want them to actually output or something like that, you need to write inside your script or your command a call to print. You need to say, all right, create P, which is going to be my ggplot object, and then at the end I want to see it, so print P. You might need to write that inside your script. Otherwise, you'll run it and you'll feel like it didn't work or didn't do anything. Chances are it actually did create the plot, you just forgot to tell R that you want it printed out. Okay. Sometimes our data needs to be transformed or summarized before it's mapped to an aesthetic. Okay. So, for example, when you make a histogram, effectively you're creating a bar plot, but what you're doing first to create a histogram is you've got to create a summary frequency table where you count how many observations fall within a certain bin. You create that frequency table, and then you plot that frequency table as if it were a bar plot with no gaps in between the bars. ggplot often has things that do this, like geom_histogram will automatically calculate those bins and plot those for you. But if you're doing something a little bit odd or a little bit out of the ordinary, you might need to keep in mind that I've got to calculate the statistics myself first, and you might need to create a separate data frame that has created these summary statistics that you want to then graph. But chances are, if it's a generally a fairly common type of graph that you're going to produce, ggplot, somebody has probably created a geometric object for that. Okay, and again, as always, go to the reference, the man pages for ggplot, and you might see things that has been done already. All right, we'll probably run out of time here for this, but the three basic ones and most important ones will be the point geometry, the line geometry, and the bar graph geometry, okay? And if you think about things like a histogram, it's really a bar geometry with extra steps before the bars are being plotted, okay? All right. Let's we'll save the rest of this for Wednesday. Okay, so on Wednesday we'll pick up here and cover these geometries. But yeah, the main idea of GG is mapping data attributes to aesthetic attributes. Okay, if you get a hold of that, then ggplot will make sense. All right, we'll see you guys on Wednesday. Good luck.